let us move to the this statement. So all of you remember this theory. Examination, one theory question will be asked. So today onwards, this material will be shared with you. You must write in your notes, and the very first question, if not problems, which question will be asked? Explain, state and explain KVL. State and explain KVL will be asked. Okay. So first we are writing statement. In intermediate, you are having KCL, Kirchhoff's current law, Kirchhoff's voltage law. So now all of you. So who has mentioned this plus V or minus V means Kirchhoff's. Already I have applied here. Now all of you, what is this KVL? Says that. What is this KVL? Anyone read out? The first word is what?
The algebraic voltage.
Yes. Algebraic means in our language plus or minus. I don't know whether V1 is plus or minus, whether V2 is plus or minus. So we write the algebraic sum of voltage sources. Voltage source, another name is what? Anyone tell me? What is another name of voltage source? Battery. How many batteries are present here? 2. The algebraic sum of voltage sources is equal to algebraic sum of voltage drop. What is voltage drop? Yesterday in those points I have given. Anyone tell me? Voltage drop means, according to Ohm's law, what is the formula for voltage? V is equal to I into R. All of you remember, what is the formula for voltage? V is equal to I into R. So I request everyone, you see number of times yesterday's video and write that circuits, that logic in the notes. Those points should be there in the notes. Oh, is it okay, all of you? In the YouTube link, it is there, the points. And this notes should be written as it is, the problems and what we are. And yes. And don't copy. Just understand. See, please mute. Don't just copy. In a cool manner, you write in your own. This is your technology. So what is KVL, anyone? Algebraic sum of voltage sources is equal to algebraic sum of voltage drops in a closed mesh. What is mesh? I will tell you later on. Okay. So this is the loop, and let I be the loop current. Now anyone tell me what is the equation for this circuit? Come on. You must explain this one. How many voltage sources we are having? Every student listen now. How to write the equation? How many voltage sources? 2. V1, V2. And always we have to draw the diagram, current flowing in clockwise or right hand side. Now you tell me, it is plus V1 or minus V1? Conventional current.
Plus V1.
That yesterday's video will help you out. Conventional current of V1 and loop current, both are in same direction, V1. What about V2?
Minus V2.
Because loop current is flowing in clockwise.
It's opposite.
It opposite, the conventional current. Now this is what engineering. So we have to assume, which is not shown on this circuit. So both are in opposite direction. So we get minus V2. And remaining part is what? I into R1 plus R2. I into R1 plus R2. So you have to draw the circuit and write the equation. That is what examiner will see. So this is what we say, algebraic sum of voltage sources. All the voltage sources should be written to the left hand side. And all the drops, I into R1 plus R2 is nothing but drop. Now all of you, now I am presenting you the definition of the mesh. So all of you, what is this closed area? Anyone tell me? Please, yes. Loop.
Loop current.
It is called the loop. In our language, yes. It is loop, current is flowing, but closed area is loop, empty space. Okay. So now we say the new word is called mesh, M-E-S-H, mesh. Okay. So, yes. Please unmute when question. You see that when you are unmuting, you are at lonely place. Okay. Because the same same disturbance is reflecting here. Okay. A mesh is a part of loop. Simple language. Now once again I am telling you, nobody will ask you define mesh. Okay, a mesh is a part of loop. Mesh currents. Now once again, what are mesh currents? Really mesh currents are flowing? No. Mesh currents are the imaginary currents. Once again, mesh currents flow only in single mesh. That means now you see the next type of circuit, all of you. Now you are able to see. Now this is the loop. Okay. Now loop is divided into smallest part called meshes here. So in one building, let us say I'm saying 50 rooms are there. So we say 50 meshes are there in the building. In each room, in your house, you are having the switchboard or not? All of you. Yes or no?
Yes,
So in each room, we are having the
Yes,
voltage
sir.
source. Your switchboard is the voltage source. So how much current is flowing through your fan inside the room, you have to calculate. So now onwards, what are these circuits? Now I'm asking one simple question. So you might have studied series circuit, parallel circuit. Tell me, this is series or parallel? So one logic, one simple question I will ask you. One second.
series.
Series
One
circuit.
second, 1 second. Okay, we are back to the screen. 1 second. All of you on the screen, I'm just putting 1 second. So this wire and this, okay, let us say these resistors, this is one resistor, this is another resistor. They are connected in series or parallel?
Series.
Series. Okay,
Series, sir.
now let me draw. These two resistors are connected in parallel or series? These two resistors are connected.
Screen is not visible.
We can't
Sir.
see the screen.
Screen is
Here
not.
we can't see.
Okay, 1 second,
Yeah.
1 second. 1 second, 1 second. Okay, 1 second. Now you are able to see the whiteboard?
Yes, sir.
Okay, I'm drawing
Yes,
here. I'm drawing here. You see.
Okay,
These
sir.
these two resistors, one resistor and this one. 1 second. Let us say these are two resistors. These are connected in series or parallel?
Series.
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 Okay, let me
Series,
draw.
sir.
Let me draw one more thing. This is one resistor, and this is another resistor.
Parallel.
These two are connected in. The answer
Parallel.
is all of you don't compare with the geometry lines, parallel lines. These two are not connected in our language. When they are connected only, we can say series or parallel. These two are not connected. Okay. And here also, I cannot say directly they are connected in series or parallel. We must assume certain current is flowing. Understood, all of you? We must assume certain current is flowing through the wire. That concept still will come in picture. Okay. Now, therefore, I'm saying these are not connected. The answer is, you can see there is no connection. Okay, they are not parallel. So parallel concept is different in our subject. So let me take you to this circuit. So all of you, in our subject, there is a simple, we are going for this circuit. If somebody asks you what is the name of this circuit, it is a combination of series connection and parallel connection. It is complex circuit. You are having complex numbers now in the intermediate second year. Yes or no? Complex,
Yes, sir.
yes. This is the complex circuit. Complex circuit contains series and parallel. Okay, all of you. So everywhere. So now what is that circuit? It doesn't matter to us. So you must draw this particular. Any circuit is given, you must draw this particular currents I1 and I2. Is it clear, all of you? Now this mesh. So I1 flows only in this particular mesh, and it will not come out of this particular mesh 1, and it will never flow inside the mesh 2. That is the assumption. And I2 current is nothing but flowing only in mesh 2 only, not in mesh 1. Is it clear, all of you? The new concept here. Okay.
Yes, sir.
Okay, you must draw this one. I'll share the material. Slowly you see and draw this circuit. Okay, mesh 1. Mesh is a part of loop. Okay, it flows here. So now we'll take the problem on this one. Slowly I'm just sharing each and every material. Okay. Now the new material is shared now. Okay, let me maximize this one. No need to study any textbook for BW subject. More than textbook, whatever the problems we do, it is sufficient. First 2 units, entire thing is problem. Third, fourth and fifth unit will be theory and definitions. Okay. So relax and just follow my explanation. That's enough. You are going to get complete marks, full marks. So all of you, let me.
Sir, it's not clear.
That's what I'm just modifying this one. Circuit you are able to see now. First you tell me part to part. Circuit. I'll maximize this one. I'll maximize. Okay. The same circuit. All of you see. See, forget about why the circuit is like this and what is the connection. Okay. If question is not there, please mute. Now all the students, this is the most toughest part what you are seeing right now. So I have given for your understanding. You see all of you. What is the meaning of this diagram I have shown you? Resistor is what? R2. Okay. Now listen carefully. If for a resistor, one single resistor, at same time, two currents are flowing. I1 is flowing in one direction and I2 is flowing in opposite direction. If for a resistor, at same instant of time, two currents are flowing, I1 and I2 in opposite direction, then what is our equation? Anyone read out this equation?
I1 minus
I1 minus I2.
Or I can also write I2 minus I1. Okay. We can write I2 minus I1, I1 minus I2. That means if for a single resistor at same instant of time, only one current can flow. But there are certain cases where to one single resistor, two currents can flow at same instant of time. Then we write I1 minus I2 or I2 minus I1 because they are flowing in opposite direction. If they are flowing in same direction, what will be my mathematical equation? Anyone tell me? If two currents are flowing in I1 plus I2, opposite direction minus. Okay. Sir, why you, when I have to write I1 and when I have to write I2 minus I1. So all the students, when I'm writing the equation for mesh 1, this is mesh 1, we assume I1 is greater than I2. When we are writing the equation for mesh 1, we assume I1 is greater than I2. Now similarly, you tell me when I'm writing equation for mesh 2, what we have to assume? I2 is greater than I1. Therefore, we get I2 minus I1. This is the logic. Okay. So now you see all of you, all students, if you understand first starting only, it will be tough. If you are perfect, then nobody will stop you to write the expression. Circuit is given. Okay. Apply KVL for mesh 1. Now in your brain, you just watch this mesh 1 only. All of you forget about the mesh 2. Watch only mesh 1. In mesh 1, how many elements we are having? Tell me anyone. 1. Battery, R1, R2. That's enough.
R2.
R2. So you must watch only this one. Okay. Battery, R1, R2. So now we are supposed, right? Now you tell me, all of you, it is plus V1 or minus V1? Compare the conventional current. Compare the conventional current with the I1. Yes. No disturbance should be there. And listen carefully with full brain and mindset. So V1 we have written. There is no other voltage source. V1 is equal to I1 into R1 plus, now see all of you, R1 where it is present? Only in mesh 1 or present between mesh 1 and mesh 2? R1. Tell me anyone.
Only in mesh 1.
Only in mesh 1. Only in mesh 1 means it only one current will flow. Now what about R2? R2 is where it is present. It is common.
Mesh 2 on.
It is
Between
mesh 1 and mesh 2. It is common to mesh 1 and mesh 2. So how many currents will flow? Two currents. I1 flows from upwards and I2 is flowing from downwards. So that same concept I have drawn here. Again in the examination, no need to draw this one. For your understanding, we have drawn. So two currents are flowing to one resistor at same instant of time. How to write the expression? Now you see, you read out what we have written here. R2, which resistor? R2 into, both the currents are flowing in opposite direction, I1 minus I2. Is it clear? I1 minus I2. Why I am writing I1 minus I2? Anyone tell me? Why I1 is written first?
I1 is greater than I2.
We assume here. This is the logic. Engineering is entirely logic. Okay. Right. I1 minus I2 means we assume I1 is greater than I2. So no need to explain. No need to explain everywhere. This language, this subject is all about writing expression. Now I hope all of you, we have covered with all the three elements in the mesh 1. We have covered. Now come to mesh 2. This is the challenging one. So all of you, one question I am asking. Sir, in mesh 2, any voltage source or battery is there or not? Anyone tell me? Only mesh 2.
No, sir.
No, sir.
We can ask one question. Sir,
No, sir.
Sir, what is
Only
this? Yes. In mesh 2, there is no battery, but you are drawing the current. What is this, sir? Battery is there means then only current will flow. So very first class I mentioned every time. Loop current is independent of dash. Battery. So whether battery is present or not, whether you are placing any element or not, it doesn't matter. So loop current is our imagination. We imagine that it is flowing. If battery is not there in a mesh, what we have to write? Now apply KVL for mesh 2. All of you read what we have written here.
0.
If battery
Zero.
is not present in a mesh, and all the students, now tell me, listen one thing. Don't imagine that current comes from the battery, it comes to this one, this is the junction and the current divides here, it flows I1, I2. Okay, that is a very old technique. The latest technique to solve these circuits within fraction of seconds is the mesh analysis, mesh technique. Okay, KVL mesh analysis or mesh technique. Understood all of you? Never imagine that current comes from positive terminal, current at same time it will come from the negative terminal. No, current comes from positive terminal, but that current we are not representing. We are assuming, we are working with which currents, all of you? Which currents? Loop currents. Loop currents or mesh currents? Mesh currents. Okay. So 0 is equal to, now you tell me, R3 is present only in mesh 2. 0 is equal to R3 into I2. I1 cannot flow through R3, all of you. I1 will never come to this junction. They flow only in this particular area. I2 into R3, I2 into R4. Now anyone tell me, R2 where it is present? Come on. R2 where it is present?
Between the meshes.
Between the meshes.
Between the mesh.
What happens? I2, this, how it flows, one particular condition we have to take. I2 and I1 flowing opposite direction. Now which current is greater now? We assume
I2.
I2. So
I2
what is the expression?
greater than.
Yes, we have written I2 into R4,
I2
I2 into
minus
R3, yes, R2 into I2 minus I1. So what next will I will tell you. You have to take I2 common. That mathematics with problems also will do. Okay. So first, next condition we'll see. But yesterday in the video, that problem you have understood, all of you. One problem we have done yesterday in the video. 1 second. Let me share this one. Yesterday I kept one question, one circuit. I explained in that video also. Yes, on the screen what you are able to see? New circuit, right? All of you?
No, sir.
Yes, sir. Yes, sir. Yes, sir.
Yes, yes, one new thing. Okay, this one is explained in the video, right? Yes or no?
Sir, we didn't receive any video, sir.
One
No,
second.
sir. Send a link.
No, 1 second. On the screen, what you are seeing, tell me.
New circuit.
New circuit. This one in the video was explained with answer yesterday.
Yes, sir.
Yes, sir. All of you understood now. What we have to do in between the circuit? Loop current. Okay. All the students, it is less than 1 minute. Okay. So tomorrow material will be given. Okay.